Hi everyone, welcome to Global Summit 2022 by Geekle. My name is Pedro Rojas, also known as Pete on internet, and in this talk, I would like to share my experience with an architecture that I used in a previous job some time ago. But it turns out it's a really great and opinionated architecture to build scalable applications. Of course, we are talking about the Composable Architecture. But before getting started, let me introduce myself in case you didn't know me yet. I'm married and I am father of 2 kids. I am a software developer at Meta currently. I also have a YouTube channel called Swift and Tips. By the way, I will share some QR codes for you in case you want to share to take a screenshot. But if you speak Spanish, I have also a podcast with a friend when we talk about iOS, but software development in general. So this is what I do. So let's get started. The Composable Architecture, or TCA for short. This architecture was created by Brandon Williams and Stephen Sellis. They combine many great ideas on other architectures, mainly Redux and Elm, and they combine it into one architecture that could fit really well in Swift development, in Swift language, to work really great in Apple ecosystem like iPhone, Mac, iOS, macOS, and Watch, etc. Now, the main idea is to solve one really important problem: side effects. Let's imagine that you have your application. This is your application, the state of your application. Let's say a state is simply the data represented in your app, right? And that data will be managed by that domain, right? You could have sub-states inside of that in a parent state, for example. And for some reason, you got an external change from somewhere else, right? This is simply an external change that could come from a notification, a timer, or simply any code executed in consequence after something happened, right? Let's say, for example, you receive some data, right? And then for some reason, later, you got the call of this restore items method. But this is not expected, right? But your application maybe is so big, so large, that you didn't catch that properly. This sounds like, oh, duh, this shouldn't happen, right? But in reality, when we have large applications, it's really hard to keep all of that in a really organized way. So one of the ideas of TCA is to solve that and manage all those side effects, all those consequences that are triggered by other effects or other events in your app in a better way, because all those scenarios are bugs in your application. The concept of TCA is to be opinionated. Opinionated about many things, about all the concepts that we want to talk in just a moment. Let me show you how TCA works in a diagram. For example, you have a view, a simple view with a button, okay? And then you press that button. That button will send an action, right? In this case, an action is, we will see specifically how that works. But that action is represented by an enum, right? A list of actions that you can do. That action will be received by a reducer. That, in simple words, is a function. You could see this concept of reducer in many architectures, especially Redux. In fact, TCA is a Redux-like architecture, sorry. So, but it's a function. That reducer is managed by a store. A store is simply an object that keeps alive your information about the state and how that state will be mutated. In fact, the reducer is the only one capable to mutate your state. And normally, in TCA, the state is represented by a struct. Okay, so once the reducer mutates the state, of course, the state will trigger an update in the view, right? And but there is more. before finishing the state mutation, it's mandatory that the reducer returns an effect object. That, in simply words, effect is an object that captures, that wraps events from outside world. Okay, like for example, notification or network calls or anything that it's, think about it. Those events are really complicated to test, right? Well, those events will be fit in an effect. The effect will be manage that logic. Okay, so it's a really convenient way, because we will see later that we could then track what are all the side effects one after other. And this will give us flexibility of when or how to call all those. But the idea is that the reducer is always returning an effect. Okay, and we will see when if we don't have nothing to return, we will see how to manage that. But keep that in mind. The effect also can trigger or send other actions, and then, well, it's a cycle until we don't have any other effect. And lastly, the reducer can interact with a concept called environment. That TLDR, those are just dependencies of your application. For example, URL session, what else? Any framework that is in the outside world that is out of your control, okay, will fit in the dependencies in the environment object. That's the overview of the TCA architecture. In this talk, we will explore quickly those 5 concepts. Let's start first with the basics. It turns out TCA is not just a concept. It's actually a library that you can use and incorporate in your project. To do that, you just need to add a package like any other Swift package, and then step number 1 is create your state. Let's imagine that we want to create a simple application, one screen, where we show a counter, and we have 2 buttons, one to increase the counter and another one to decrease it. In this little example, the counter is the only property in our state, right? And we'll initialize it as 0. Then we have the actions. As we said, we have 2 buttons, one to increase the counter and one to decrease it. So we are representing this into this enum. We have also the environment, although here we don't need it, but the TCA library is requiring this environment object, so we're gonna leave it empty for now. And we have the reducer, that is just a function that manages 3 things: the current state of your application, the action that someone provides to the reducer, and access to the environment object, which contains the dependencies. We don't need it here, but again, it's part of the requirements of TCA reducer. So in this example, state is an in-out variable, which means we can update it. It's mutable. What we are doing here is just a switch with actions. Okay, basically that. So we have 2 actions. So what will happen when we increase the counter? We increase the counter plus 1, and otherwise we decrease it by 1. It's that simple. But the important part here is that we need to return an effect object. Since that this example is really basic, we don't need an effect per se. So we can return just a simple effect.none, and we will satisfy the reducer requirement. The view will keep the store that we saw, that keeps the reducer, the environment, and the state. Okay, it will get access to identify what is the state and what is the action inside of it. But however, the store that you are seeing in the screen is cannot be observed by the view. So in order to do that, TCA provides a concept called view store. That is a store like the regular store that you are seeing here, but the only difference is that it's observable. It's an observed object internally. For that, in SwiftUI, we can use this with view store wrapper that will provide a view store object for you for free. By the way, I didn't mention this, but TCA is available for UIKit. But in this example, we want to use SwiftUI. In order to send an action to a reducer, we have to use the view store and then use .send and send the action according to an action that is matching the store. So in this case, we are sending decrease counter and it's perfectly working. And finally, we want to initialize the view with a store object that, again, it keeps the state, the reducer, and the environment. That's it. That's the minimum requirement for a TCA project. So let's see a demo. Here we are. So in this example, we have, again, the state, the actions, the environment, the reducer. It's mutating the state, and it's returning an effect. And next, we have the view that keeps a store, and it's wrapping the store to get a view store. And then with this view store, we pass an action. In the case of the decrease button, we send decrease counter. And for the plus button, we send increase. So we can see that this demo is working as expected. It's minus now. Yeah. And we are initializing this with this store object. Although since this is a preview, well, this is basically the same initialization here. That's it. You have your first TCA application ready to go. All right, that demo was too simple, but it will be part of a much larger application. We're gonna build an online store where people can select the number of items that they want to purchase and pay them and send them to API. Okay, there's not enough time to build it actually, but I will leave you that QR code in the screen, and then you could have access to the full demo that I did for you. All right, so just take a look later after this talk. Let's focus on some key pieces about how TCA can help us to build this. First, compared with the previous project, here we have many more actions to do. We can open a cart, we can add an item to a cart, we can increase or decrease the product quantity, etc., etc. So even fetching the products from an API, it's a more realistic application. We're gonna do that by using composition. Let's imagine that you have a Lego, right? And with that, with many Lego pieces, you could build something as cool as a train, for example. By the way, those are my kids having fun at Legoland. Anyway, so following that concept, we could have this application, but maybe it's too large, right? I mean, working with MVVM or other simple architectures could be okay, right? But depending on how large is your team or so, maybe it's better to split the responsibilities and the concepts in pieces. So that's what we're gonna do here. We will start with a simple counter demo and then create an add to button, then put that button into a much larger product cell, and then finally create a product list with everything else. Remember, this is the TCA diagram, but in fact, every system in TCA or every domain keeps all of this. So what I try to say is that our previous example, it's basically representing all that information, all that diagram in a single domain, add to cart. But now with this much larger app to represent an online store, we're gonna add this subdomain into another systems and other domains that are larger. For example, product will keep add to cart, and product list will keep everything else. Each system has its own way to manage the state, but the parent system will not touch the child system. But anyway, they need to know that exist in case some side effects will be produced in consequences of internal actions in subdomains. But first, let's go back to add to cart. This is basically the previous demo. I created a struct that fit the state, action, environment, and reducer into a struct to have a control about the state and action environment are from add to cart domain. Although it's not required, I mean, you could create your add to cart state, add to cart action, etc. But I prefer this way to work on TCA. So view. So as you can see, maybe the names are a little bit larger because the dot state, dot action, but it's basically the same. Here we are just changing things a little bit. It's the same domain, but we are changing the UI depending on what happened. So in the previous example, you can use negative numbers, but here we don't want that. We don't want a -3 product. That doesn't make sense. So here it's just if it's greater than 0, we wanna display the add to action button that we know. Otherwise, we will show just a single add to cart. Now let's go to product. Product is a little bit more complex than the previous domain. We have a product, we have account, but here we are keeping the add to cart state. So the parent domain will have to have a space in its domain for the child domain. For this demo, we don't need anything else that just represent an action that has a whole represent something for add to cart. Okay, this also require again to capture any event coming in consequence of something done in add to cart domain. For example, if someone press an increase button, okay, here later in the reducer, we could be capable to capture that. Okay, add to cart, for example. We can capture when someone did tap a button or did tap a minus button. However, the magic happens when we combine the reducers. So for example, this reducer won't do anything if we press the plus button or minus button, because we will never get add to cart actions from here. What we have to do is to combine this product reducer with the child reducer. And to do that, we're going to use a pullback operation. That it's simply bringing what is in the child state, the child domain, to be capable to work together with the parent state. But the idea is that with this operation, you are basically putting everything here from the child domain or many child domains. And once all the operations are done, then the parent domain can do something in consequence of the child domains. Okay, so now let's jump to product list. It's basically kind of the same, except that here we have a list of states, and we will represent this not just as an array, but TCA has its own array for states in TCA, which is identify array of. This is an optimized way to work with a collection of states in TCA. Here we will have a list of products, but in this case, all of them will be represented by a state ID and any action provided. Oh, well, by the way, here we will have to fetch products. And here is the first time when we use environment objects. So in this case, we have two. We have an environment object that represents a dependency with a function to fetch products. Who will be the provider? We don't care, but it's a function that provides products. That's the only thing we care. And a UUID that will be useful for testing later. Here, we also need to combine multiple reducers. But here, we need a special one that works, has a fallback, but for collections, which is a for each that it's capable to read whatever is happening on the other reducers and then act in consequence depending of product domain or any product domain. That's why we need the ID, because it will be part of how we identify any specific product ID doing something. For example, a cell that is tapped and how to register the quantity, the amount of product coming. And of course, here we are fetching products and we are using the environment to do that. We are using fetch product environment, whatever is the provider and whatever is the UUID provider. We have the view and we have here another feature that manage the store of a collection of stores. In this case, the product list state. And we use for each for that. It's help us to represent all of that in the screen. And as an example, we are using on appear to invoke and fetching the products from the API. Lastly, for this demo, we have to initialize the store. And in this case, it's basically the same, except that we are passing the parameters for the environment. In this example, we are using mock data. We are using fetch products from a sample that I did and UUID, a regular UUID. So here's where you can provide data from an API client or so. But for this example, it's just to give you the idea that you can do that. You can put anything, any kind of array of products here. So let's see a demo. Again, we have what we got in the previous demo. We have the add to cart button, and once we press it, we can see positive numbers. But if we go down to 0, we send add to cart again. If we see product domain, we will see this pullback again. Okay, so this is the way how we can listen from actions in child domain. And for example, here that we are using the tab minus button, only get the maximum between 0 or the state count -1, because we don't want to use negative numbers here. And the list domain again. So it is like a pullback to listen what is in the child domains, but for a collection of domains. All right. So for example, we can see that we can press whatever it is here. And I also added the go to cart because, well, we don't have much time. But look, we got the cart list and the list that we selected. We selected 4 and 1 respectively. So yeah, this is working as expected. Now, let's see quickly effects. For that, we saw that we added a few other domains, cart list or cart item. So now for product list domain, we are making those methods asynchronous. The only difference here is that when we fetch product, we need to wait a response. And here we're gonna use task result that is also provided by TCA, but it's just a convenience result object to manage a success or failure case. And look how we use the fetch case here. So we are using also a effect task that is provided by TCA. And we have to wait for another action that is fetch product response, okay? And it's executed a task result that is invoking the fetch product function. In this production version, we are calling a URL session, and we get the data from the network. Okay, and once we get the data, depending if it's success or not, we can process the information and build or product list state, or just print an error in this case. This is one of the most common examples, just calling something from an API waiting for a response. That's a great example for side effects. But also, there is another one where we got something, we need to call something in consequence of any other action happening in the application. And TCA can manage this really great. So for example, we have something in the cart and someone deleted a product, okay? So we need then to remove the add to cart values to 0 because there are none in the cart anymore. So with TCA and this whole reducer, all the reducers combined with the combined operation, we can detect, oh, okay, a cart item, send an action, delete cart item for a specific product. And then we can execute a side effect that happened, reset product or do something, okay? This is really convenient, and we'll see right now how to test that. So here we are. We have a list of items again. We go to cart, and for example, if we remove this item and we close it, you can see that we'll store the state of this domain. So we did that here. We got this cart item, this cart action, and inside it was produced something from the cart item. We detected that it was a delete cart, and then we execute a reset product task. With this basically, well, this is really maybe not super efficient, but what we are doing is just identifying what was the product state, and then resetting the count of that state and also the one from cart state domain. And in that way, we keep our data consistent across all these effects. And other important part here is the effects. So, no, I mean the environments. So here, again, we have the fetch products, but the way we are initializing this is through, let me see. This is a much larger example, but here we have this root domain that it's managing, again, the product list. And here we are creating this live object to represent, the production version. But here we can see the fetch product version in production. And yeah, this is how we are doing this. So we are calling fetch store API, and we are doing a URL session action. So, but here it's totally isolated from our project, even though this could be outside of this Xcode project. But yeah, you get the idea. So you can mock your data, but also you can build this kind of live objects to manage your information. And here you can see that product list domain environment is getting fetch product values, and also the others to send orders or UUID. Lastly, let's say testing. This is one of the most powerful features of TCA. For example, if you want to test the fetch product success, instead of initializing a regular store, you initialize a provided test store from the API. You do the same. You initialize the state reducer environment, but here you initialize a list of products that you are expecting. And here you have to send an action to the reducer, which is fetch product. In this larger example, we are adding status loading to see what's going on with the data. So here we are getting that we are loading the data, but then we need to capture what is the received action in the domain, in the reducer. This is great because you should expect something, and if you don't test this, TCA will produce an error in your test. You could be confident that whatever you are doing, you always will be testing end to end. This is good and bad, but I mean, it's what it is in TCA. So I would like to hear your comments about it. So let's see a little demo about how this works. We have a list of products, the domains that we want to test. We have this fetch product. We are waiting for this. So let's comment this for now. And then run this test and see what happened. We got an error. And this is because the store received one unexpected action that we didn't process. This is great because we can see that something happened. We have to also get a fetch product response, which is this particular code here. So, okay, this is awesome because if we forgot to do that, TCA will tell us for us. Okay, now also the interesting thing here is that we need to add how the data is mutated. So for example, let's say that fetch product is the action, but if we send we're gonna send North Star for some reason. Then if we run this again, we got a fail because the data is expected to be loading, but we send not started, and we can see graphically how the data should be instead, or what we receive actually. This is amazing, really amazing. But again, loading. Let's see what happened now. Great, we passed the test. There is a lot to explore, but this is my experience with TCA. I used to work in a company that produced a wearable device to deliver insulin, which is a really great product. And I was managing a team of iOS engineers. In short, this architecture is great for large teams. If you have a team, I don't know, it's maybe subjective, but let's say 40 iOS engineers in your team. This is awesome. This is one of the best architectures you could use to build your application. Of course, that will depend of your requirements or something. I'm not saying this is a silver bullet, but it's a great architecture in my opinion. This is also something to consider. The learning curve or TCA is harder. I also mentioned that exhaustive testing is something to consider. It's a trade-off. Some people don't like it. And of course, the domain ceremony that, create the state, action environment, and sometimes the empty environment. It's empty environment. But I have good news for you. The TCA team is working on changing this concept. For example, all like we saw about building the state, action, environment, etc., transformed into a ReducerProtocol that it's capable to have associated types for action and state, and create a function when you get add a reducer and structure this process, this workflow easier for you. This is coming. This is still in beta, but if you want to take a look, I really recommend you and check out the TCA GitHub page. That I will give you in just a moment. That's it for me. So those are my contact, my YouTube, Twitter, podcast, and a link to a TCA GitHub page that will be really useful for you. That's it for me. Thank you so much and have a great day.